Redox reaction, what's going on are actually two things. Oxidation is the loss of electrons. This is a mnemonic. Oxidation is loss is OIL. And this is the zinc lost electrons and became the zinc ion. Meanwhile, copper gained the electrons, and this is the other half of the mnemonic. Reduction is gain. So that was the copper ion, picked up 2 electrons and became the copper element, just copper atoms. There's another mnemonic which is Leo, the lion, says Ger, L-E-O-G-E-R, which is loss of electrons is oxidation, and gain of electrons is reduction. Reduction means that electrons are added. What is reduced is the charge value. So this went from +2 to 0. That's reduced, going in the negative direction. And this is kind of opposite in the thinking, like, well, this gains electrons. Why is it reduced? The charge value is reduced. And this is oxidation, means that electrons are lost, and so that's an easy one. Electrons are lost, they're kicked out, they're on the product side, they're on the right side. And so this is a flow of electrons from the oxidation to the reduction, and that flow of electrons is transfer of electrons, and that produces the electricity. So half reactions. These are different from what we've seen before. Half reactions are used to show only the electrons that are lost and gained. And so it's not a complete balanced reaction that we've been seeing. It is the same elements on both sides, but what's shown here in this half reaction are charge values, and we're not allowed to show charge values typically in balanced equations. So this is only to show, the half reactions are only used to show those electrons, and the electrons are either going to be on the right side, and on the right side that means electrons are lost, or on the left side, and that means electrons are gained if they're on the reactant side. So this is the oxidation half reaction. Oxidation is lost and electrons are on the product side or on the right side. Reduction is gain and electrons are on the left side, and that's the reactant side. And so that doesn't matter how many, the number of electrons. These are all examples of different half reactions, but just if you have that E symbol, okay? And so electrons on the right versus electrons on the left is all you have to look for to define the oxidation or reduction when you are given a half reaction. So when you put these two half reactions together, you have a complete balanced equation, and that does not include those electrons. So that's why you have half reactions, is that helps us identify. And these electrons end up canceling out when you show the complete balanced equation. You don't see electrons on either the right or the left in a balanced equation. So we're going to determine what's oxidized and what's reduced when you're given a balanced chemical equation which does not show the electrons. So the starting point is that you have to know this. You have to know that oxidation is loss and reduction is gain. You can use this oil rig or you can use Leo-Ger, but that's the starting point, is this mnemonic. Okay. Then when you are given a balanced chemical equation like this below, balanced chemical equation is not the half reactions. So we have to start by figuring out those half reactions. So this is looking at each element or ionic compound and determining the charge values, and that will help you write the half reactions. So start with, this is magnesium, which is an element. This is not a +2. Even though magnesium forms a +2 ion, when you are given a balanced equation, this means that you just have the atom magnesium with a 0 charge. So anytime you have an element alone with nothing bonded to it, it has a 0 charge value. This is also true of Br2. So bromine is in family 7, and those are always diatomic. This is 2 subscript, so that means there's 2 bromines bonded together. This is not an ion either. Even though elements in family 7A form -1 ions, this is not a -1 ion. This is bromine alone. And so just like magnesium alone is a 0 charge, bromine alone, not bonded to any other atom, is a 0 charge. This on the right side is magnesium bromide. So this is an ionic compound. It's a metal plus a nonmetal. And these are the ions that you can determine from the reverse crossover rule. So remember, you use, when you're writing an ionic compound chemical formula, you write the charge values from the family numbers and then you cross those values over and down. So to figure out the ions, you're actually going to do the reverse of that. So you're given MgBr2 is the chemical formula of an ionic compound. So you take this 2 and you pick it up, and it becomes a +2 charge on the magnesium. And then the bromine does not have any number that picked up, so this is just a negative charge on the bromine. So then you're going to write the half reactions, which are Mg0 with an arrow and then Mg on the other side +2. So the charges are not equal on both sides. In order to make them equal, this 0 has on the left side needs a 0 on the right side. On the right side it's +2, so you're going to have to make a -2 by adding 2 electrons to the right side. So that's one half reaction right there. Mg goes to magnesium +2 ion +2 electrons. And this the bromine, is another half reaction starting point, which is Br2 with a 0 charge on the left side, and then on the right side Br minus, and there's 2 of those, you can put a coefficient, Br minus on the right side. So here again you don't have anything equal. You have 0 on the left and -1 on the right. So in order to make the charges equal, you have to add a negative. It's all from the perspective of electron. So adding 2 electrons on the left side would be 2 times -1, which would allow for -2 on the left side and equaling the 2 times -1 bromine ions, -2 on the right side. Now there are 2 half reactions. This is the magnesium half reaction, and this is the bromine half reaction. So from the 2 half reactions, there's electrons on the right side, that's the product side. So this half reaction for the magnesium is oxidation. So magnesium is oxidized. This half reaction with bromine has electrons on the reactant side, on the left side, and so this is the bromine is the element that's reduced. So this is one half reaction has to be oxidation and the other half reaction has to be reduction. And both of these are going on at the same time in this balanced chemical equation.